So now we have another triangle problem where we need to solve the triangle, which means that we need to find all the sides and angles that aren't given. However, it's in radian mode. So make sure you have your calculator in radian mode if you are going to be needing it. So the first step is to draw our triangle. And it tells us that C is pi over 2. Now recall that 180 degrees is pi radians. So if we have a 90-degree angle, it's pi over 2 radians. So this is actually our angle C. We're also told that angle A is 8 pi over, 8 pi over 45. And that's our measure A, and then our angle A, and then our side, which is across from that, is 24. So what we don't know is side C, side B, and angle B. So the first thing we're going to do is find B. So again, since we have 2 angles out of 3, what we're going to do to find angle B, that's the symbol for angle, is we are going to take pi, we're going to subtract pi over 2, and we're going to subtract 8 pi over 45. So if you did it manually, you need to find a common denominator, which is going to be 90. So we're going to have 90 pi over 90. 45 pi, and then this is going to turn into 90, and then this is going to be 16 minus 16, and then this is 90. So 90 minus 45 minus 16 gives us 29 pi over 90. So that's the measure of angle B. Now, if we wanted to find C, side C, again, we can either use our new B measure or the 8 pi over 45 that was given to us. So I'm going to use the 8 pi over 45. So since I'm dealing with this angle, then I need to have C as part of it right here. So I'm going to do 24 and C, so that's opposite over hypotenuse, so that means I'm going to have to use sine. So sine of 8 pi over 45 equals 24 over C. To solve, what we're going to do is we have to multiply C by both sides just to get it out of the denominator here, and then you're going to divide by our sine of 8 pi over 45. Sorry, my handwriting is a little messy. So this cancels, so we're going to have 24 over sine of 8 pi over 45. You can plug it in your calculator just like that in radian mode again, which is about 45.290. Okay, and the last part of this is finding side B. So again, I would like to stick with the same angle. So to use B, I'm going to use 24 and B, which is opposite over adjacent, which forces me to use tangent. So I have tan of 8 pi over 45, which equals 24 over B. And again, we have to multiply B by both sides and then divide by tangent of 8 pi over 45, which is about 38.408. Okay, so we're going to do an application problem, and I have to apologize in advance if you hear that noise in the background. My dogs are chewing on their bones, so at least they're not barking. Okay, so an airplane is flying at an altitude of 10,000 feet, which is approximately 1.89 miles. if the pilot calculates his required angle of descent to the airport to be 2 degrees, how far is the airport? So I'm big on pictures. It definitely helps determine, or it just helps visualize. So if this is our airport right here, we have like our control center. It pretty much just looks like a tree. It's pretty bad. Do it like this. I don't know if that's better or worse. Okay, so that's our control center, like our airport. All right, then we have a plane, and my plane skills are apparently awful. My class tells me, so I apologize for that. This is my little plane. Okay, so we know we're flying at a 90-degree angle, and he's approximately 1.89 miles in the air. So 1.89 miles. And all we know is that he has a descent of 2%. So that doesn't mean, you know, what's his angle from the airport to where he is in the sky. That means if he's traveling along this line right here, his angle of descent is actually in this direction because he's going down. So that means that this angle right here is 2 degrees, making this one within the triangle 88, because it forms a 90-degree angle, and 88 and 2 is 90. So since, for the same reason, you have 88, 90, so you have 2 degrees down here also because they are corresponding. So now we have to figure out how far away from the airport he is, which is right here. This is our x value. We don't know. So to do this, you have some options, given that we have all of our degrees here, or all of our angle measures. But what we do have to use is the other side, which is 189. So let's say we use the 88. Then we need to use x and 1.89, which is tangent. It's opposite over adjacent. So we're going to have tangent of 88 degrees. And again, you need to be in degree mode in your calculator if you're not already. Equals x over 1.89. So you multiply 1.89, meaning x equals 1.89 times tangent of 88. And you could plug this in just like this in your calculator, which equals about 54 miles. So this next picture just pretty much talks about kind of what we just did, an angle of elevation and depression. So very similarly, if you're a person and you're looking at something, that's pretty much your horizontal. That's, you know, straight ahead of you. And then if you look up at a building or a person in the window, your line of sight then became an angle of elevation. You're raising your line of sight. If you're looking down at someone lower than your eye level, that is an angle of depression. So you're pretty much looking up or down. So for this one, from the foot of a building, my angle of elevation to the top is 80 meters away, or 80 meters away is 22 degrees. From the roof, I have to look down at a depression of 50 degrees it took to look at the top of a tree. Okay, so again, I'm going to draw a picture the best that I can here. So if this is the building, my little windows, then it says from the foot of the building my angle is. So this is the ground, and the person from the foot of building. Then so we're looking at a tree. So over here is a tree. So the site is 80, so I'm 80 meters away. So from this point to the tree, 80 meters. Okay? So then looking at the top of the tree to my level of sight is 22 degrees. Then it says from the roof of a building, so if the person's up here now, I know I'm not drawing these to scale very well. I have to look down at an angle to look at the top of the tree. So if I'm above the tree, then, actually, I need to draw my person a little bit bigger so he's higher than that. So if I'm looking at the tree, so the line of sight is right here. And then if I have to look down at the top of the tree. Okay, so there's a couple triangles being made here. And this is our, so we have, this is, we're going to call it H2. And then I'll use a different color. Our first height is my level. So pretty much if I'm standing, my eyesight to the top of the tree is height 1. We need to figure that out. And then it says if I'm on top, my eyesight to the top of the tree is my second height. So we have 2 heights there. And then we know that this is 50 degrees. Sorry, I'm writing over my words. Okay, so I think this is pretty much it. So what we're trying to figure out is how tall is the building? So we don't know. And if I'm exactly 2 meters tall, which we do know, how tall is the tree? Okay, so what I need to figure out the height 1 or heights of 1, that H1 and H2, because then if I add those two together or use both of those, I can figure out both the building and the tree. So first thing I'm going to do is use this 22 degrees right here. So I know that the base here is 80, and I know the angle is 22. So if I need the opposite, and I have the adjacent, that's tangent. So tangent of 22, and it's degree mode, equals the height 1, which we're trying to figure out, over 80. So we multiply both sides by 80, and we get that H1 is about 32 meters. Okay, so now I need to figure out H2. So very similarly, this distance over here is also 80. I know my picture's not totally drawn to scale, but essentially the person's right here on the building and standing right here on the building, so making it both be 80 meters. Maybe you can draw a better picture than me. I apologize. Okay, so, and now we're going to use the 50. So we don't know the opposite, and we have the adjacent. So we're again going to use tangent, but now it's tangent of 50 degrees equals the second height, which is the smaller one, over 80. And when I get that, H2 is about 95 meters. And again, not drawn to scale because it looks like H2 would be smaller, which it's not. So again, just keep that in mind. So how tall is the building? Well, the building are the 2 heights put together. So the 2 heights put together, so we have H1, so the answer for A is H1 plus H2. And when you do this, you get 127 meters. So visually, this is kind of hard to see because you're like, well, wait a second, the building it's not the same height. But what we're missing here, if we add H1 and H2, what we're missing here is this part of the building, the lower part. But that's how tall you are. So that's 2 meters. But then again, you have to keep in mind you're 2 meters taller than the building because you're standing on top. So that kind of cancels each other out. And then the last part is B, which says, if I'm exactly 2 meters tall, how tall is the tree? So the tree is just H1. We know that because H2 is above the tree. But you have to add that 2 meters. So that gives us 34 meters. So again, it's a little busy, but using tangent for both of these and then just some logic with the lengths that we have, we can answer these questions. Okay, so at a point 200 feet from a production building, which this is my building right here, The angle of elevation to the bottom of the smokestack is 35 degrees. So, to the bottom of the smokestack would be 35 degrees. So here's my line from a point on the ground, and we know it's 35 degrees. What we also know then is that from that point to the smokestack, it's 200 feet. And the angle of elevation to the top is 53. So if this is the top of the smokestack, now we have an angle of elevation like this. Okay? So that whole thing put together is 53. Find the height of the smokestack. All right, so we have two heights here. We have, let's say, height of the building, and then we'll just say, I don't know, h of t, ht, which is height of the whole tower, if you will. So pretty much what we're trying to look for is this height right here. Well, to do that, we need to find HB and HT. So if we want to find HB, we need to use 35, not 53, because 35 is connected to the tall end, this height of the building, which we know is 35 degrees. So we don't have the opposite, but we have adjacent. Again, this is tangent. So we have tangent of 35 degrees equals height of the building over that 200 meters or feet that we're away from it. Again, multiply both sides by 200. Make sure you're in degree mode. And then the height of the building is about 140 feet. So now, to find the other height, what we need to do is the same thing, except instead of tangent of 35, we're going to use tangent of 53. Now it's of the height of the whole tower over 200, and when you multiply, you get a height of the tower which is about 265 feet. So if you want to know just the smokestack, then we need to do a subtraction problem. So the height of the smokestack, I'll just call it H, is 250, I'm sorry, it's supposed to be 65 minus 140, which equals 125 feet.